All right, welcome everybody. It's another ChatLoopBackOff. We have Carlos back. We're going to talk about KubeStellar. You already got Gen AI spitting out stuff here on some Jets, NVIDIA Jetson hardware. So with that, Carlos, take it away. And as usual, I'll be in chat.
Thank you, George, and welcome everyone. As folks join, let's see who's. I have echo, George.
Yeah, you paused for a good while there. I think you had a network hiccup. Try talk for a bit.
Yeah, I'm here. Can you hear me?
Yep, you sound great now.
I have like feedback from somewhere. Are we still alive?
Yep, you're live. You sound great here. Let me see what chat says.
There's. I think we have a
KubeStellar's ready to
problem.
rumble, so that we got that going on. Oh,
Yeah, we
do you
still
have a
have
tab
feedback.
with a YouTube URL open?
No, I don't have a.
Sometimes I tend to outsmart myself with the open preview window. Yeah, they don't hear the echo. I think only you hear the echo.
Let me see if I have a window open.
Yeah, that's what I'm thinking.
Oh my God, what's going on? I have a bunch of things open. Let me close most of the things. I have an echo on myself. I don't know why.
Yeah. Would it work if you remove one earplug?
Let me see.
So maybe it's not so annoying
So
for you.
if you can hear me, I would just unplug myself and then everything is on chat text.
Yeah, that works.
Okay, let's go with that.
All right, let's get started.
Okay, so if people can hear me, that's okay. And George put the comments in the chat, and then I'll see you. Also, we have a private chat, George, so you can ping me also in private chat. Okay. So with that, I think I see people. Saber says hello. I don't know if you can put that on the screen. Paolo Detroit says I can hear me fine. And if anyone else is watching live, this is the chat loop back off that we do every Thursday. Usually the host is the CNCF Ambassador. My name is Carlos Santana. I work in AWS as a solutions architect for EKS, but I'm also for this project CNCF Ambassador. And today we're going to discuss a project from the CNCF called KubeStellar. And let's take a look at what KubeStellar is. Usually the first thing that I do is go to the CNCF landscape. Just for folks that are not familiar with it, usually people get very scared about this. And then you can find KubeStellar here. KubeStellar is a sandbox project. One of the things that I tell people is you can filter here by only CNCF projects, hit apply, and then that becomes a smaller window. Let me see, it's right like that. And I think I have some news. So talking about sandbox projects, we can filter by sandbox project. So KubeStellar is a sandbox project. So let me filter by sandbox project. We have a couple. The thing that I wanted to highlight today that I have in my show notes was that I think that's the only thing I have for news is that there's it's a GitHub repo in the CNCF called Sandbox. I think this used to be in the TOC repo, but now it moved to the Sandbox repo to be able to manage it better. So if you have a project open source and you want to make it part of the CNCF or donate it to the CNCF, right? Because it becomes IP from the CNCF, you will need to go and open an issue following a template that they have. And you can see here that there's a lot of them are new already. Some of them are already onboarding, like Open EBS is onboarding, but wanted to show you that we do them in batches. So if you go to milestones, you will see that the next milestone is next month. And next month, we have a total of 20 projects that the TOC would need to look at. So things that are here are things like Spin and SpinCube, which is allowing you to run WASM applications on Kubernetes. We have other things like K0S, which would been around for a while. It's a very small distribution of Kubernetes. We have Cloud Native PG, which is an operator to run Postgres SQL. Folks from Red Hat, it looks like they're donating Podman and the Podman tools. Hyperlight is a project from Microsoft on running Rust library to run hypervisor functions. So I think this is the fullest pack of Sandbox projects being reviewed. So the TLC has a lot of work ahead of them to review. So they are going to go into review in January 2025. And next to it, you will see things like app delivery, like the tags that also help review them first. So they will go to a tag, get reviewed by tag, and then they will come back. So if you want to learn more, that's where you can find that information. Usually try to come up with something that people may not be aware of it. Oh, I think I stopped sharing. My bad. Let me share again. I think, George, you have to put me on sharing again. I think I clicked the button, stop sharing versus hide. A little thing that says hi here. Okay, we're good. And then Braulio Dumba says hi. Franco says hi. And today's project, let me go to the Sandbox, is KubeStellar. I don't know how that's pronounced. But if you want to learn more about a project, you can go to CNCF, go to the card. It tells you, how many stars, commits, first contributions, back of the project. I took some notes. You can find the website also from here. This is the website. Let me take a look at my notes. What else? This is another useful thing that I usually do. That's why I was showing that website, is looking at the application. So sometimes it's good to find the background of why the project was created, where it came from. So you can see here, Andy is here, the main contributor for the project. This project came from, I believe it was KCP Edge. Is separated from KCP, but the idea is to promote a large number of deployments across a large number of clusters and small locations like Microshift, K3S, kind. And in my case, I'm running a little Jetson board with a GPU from NVIDIA that I'll be demoing how to deploy that there. And so, yeah, if you want to see where the project came and those type of things, you can see that there. So let's go to the website. This is the website that you will find. I like the fact that it has the call to action buttons. Either you want to look at the documentation or you want to join the group. I would say that the Slack is more active. So if you look at the Slack icon, they're located in the Kubernetes Slack workspace under KubeStellar-dev. I think there's another channel called users, but yeah, most interaction will be there. And the idea of this project is that they will centralize application resources for selective deployment across multiple clusters. So the main idea is that you will have multiple clusters created anywhere in any region, edge devices, Raspberry Pis, IoTs, and then you will have some type of policy to select, I want this workload or this deployment, or you can say even Kubernetes YAML, I want this workload projected into these 3 clusters or all clusters. And the way you select a workload, and you select a destination, which will be a cluster, and then deploy to those. And the idea is that it's a agent based. So let's look at the architecture. I think the architecture will explain it a little bit better. So the icon, that's what I described. From here, you will be deploying. The arrow points from the central Kubernetes cluster, which is called the hub, down to the edge clusters. But so far, I just had a day and a half of looking at the project, so I may say things that are not wrong, and some of the maintainers are in chat and they can correct me. So the idea is a pool model. Actually, there's no need to be able to connect from the hub cluster to the edge clusters. It's a reverse connection. The spoke clusters will connect to the hub cluster and then get the information that it needs. So there's no need for communication. So in my case, I'm in my house and the cluster that I'm using is in the cloud and cannot connect directly to my Raspberry Pis that I have here in Jetson, but the Jetson and Raspberry Pis in my house can connect to that global cluster that I have other workloads. So that's kind of like the agent model when we explain that. So let's go to the documentation. And then this will show you a little bit of the architecture. So the idea is that you will have a hub cluster where you're going to install, not install, but you're going to deploy. It could be a deployment, it could be a config map, a secret, those type of things. You will deploy them into a workload definition space. Once they're there, then you will say, I want this workload into these clusters. And it could be things like jobs for machine learning. It could be jobs, in my case, running a GPU workload in my Jetson, or it could be anything that you want to distribute these workloads across clusters. It could be because they have to be on location, or it could be that you want to load balance the workloads, that you have a lot of like batch jobs that need to be run, and you're monitoring which cluster has capacity to handle it at this time, and then you bind. So the idea is that you bind with a bind policy saying, I want this workload that is installed in this API server, this cluster, to be sent down or maybe pulled by the clusters, pulled down to the clusters. And then the idea is that the status of these workloads will come back to the hub. So the clusters will push up the status of the workloads. And that's something that we'll look into how to do that in detail. Let me see if there's any questions in the we use the term core for the central stuff. It's not just one cluster. Yes. It's the core that holds the WDS. I think it's called WDS, and then ITS, which is inventory and transport space. I think there's an architecture here that shows a little bit. I think this is the same thing of me as a user are going to deploy Kubernetes resources into one of these definition spaces, and then it would look into the binding information, the inventory and transport space, to send them to the clusters. The documentation explains WEC is the definition of a workload execution cluster. So these are kind of the edge clusters. The inventory and transport space is manage the inventory of clusters as clusters join. They get registered. And then since they register into the system, then the WDS, the workload definition space, can have the bindings to say, I want this workload on those clusters. Let me see down here. KubeFlex is something that they have. Is a it's a control, holds this control manager that will create the control planes for short. I'll continue using the term ITS for inventory and transport, and WDS for workload workflow definition space. So the control manager, KubeFlex will create the control planes. Control manager, these are components that still live, I think at the bottom, there's architecture here. Let me show here. So the control manager lives in the hub cluster. So you can say control plane hosting cluster. The WDS and ITS actually are API servers, Kubernetes API servers. So there's, in this scenario that I'm going to do, there are two of them, one WDS and one ITS. The WDS is where you're going to deploy the workloads and then say, I want to bind this workload to a set of clusters. And the way that it knows the set of clusters is going to the ITS to get the set of clusters available. And then once that is there, reconciles into bindings, and the bindings would actually say what is that this workload is being deployed to these workloads. Once the bindings are created, these are the desired state of like the bindings, and then they will get transported into the ITS and sit there into a namespace called mailboxes. So in the mailboxes, manifest work, which is basically is a resource that wraps all the resources that you want to deploy as one object. So if you want to deploy a namespace, a deployment, a service, maybe a PVC, all together, they will get wrapped into a managed work. And then at the bottom, you can see all your workload execution clusters, which in my case will be a Raspberry Pi or a Jetson. It will have two things. One is an OCM agent, that is the one that pulls the manifest files that it wants and then apply them. So that's, you will see apply manifest works. And then it will have a second component called the OCM status agent. That is the one that pushes up the status, collecting the status of for example, from a deployment of those workloads objects, and push them up into ITS. And then in the WDS, you can kind of like collect the status and then project them into the WDS as combined. So let's get started. The way to get started in here, that is super big. There's other components. Let me see, the control manager we talk about. Pluggable transport controller is something that implements the work status and sending down. This is also related to I think I had a work API, SIG multi-cluster project. This is from upstream Kubernetes. There's a SIG multi-cluster where is KubeStellar, you can say, is implements this type of orchestration of workloads. Usually in Kubernetes, the orchestration of workloads is you create a pod and then you find a node in the cluster where you want to land that pod. In this case, is you have a workload, and then you're looking for the best place to run this workload. And it could be in two of them, many of them, maybe for load balancing or HA, or it could be for locality. For example, maybe I need a cluster in my house because it's using sensors from my house or it's local data there. Or maybe I just have certain hardware in this cluster that this workload needs to go there. So it depends what is the policy that you put together. So in this case, you can see this is a work API, and there's other projects that implement this. I think at the bottom, they implement, so Open Cluster Management is one of them that implement that API, and KubeStellar uses that small component of Open Cluster Management, which is a CNCF project, I believe in Sandbox, that implements this manifest work API. I think this is a not found, but there's a Google Doc that talks about this. This is just an example of how it will look like. The Open Cluster Management implements it, has a specific configuration for it. So I just wanted to show the relationship between this. The other maybe question that people may have is if this is related to KCP. From my understanding, talking to the maintainers, is this was actually a project in KCP. It got disjoint, rewritten. I think it was called KCP Edge. and now can stand on its own, and it's a way of, let me see if there's some more architecture here on scaling. Yeah, maybe this one. Now this one talks about the operator. This is the Galaxy. And you can go to this one. So the idea is that when you deploy a workload, let's say a deployment to the AWS, it's not like you're transporting that deployment directly to a virtual cluster or like a representation of that cluster. It creates the binding, and it creates a bunch of bindings of like the desired state of all these workloads to 1,000 cluster, or 2,000 clusters. And eventual consistency of these agents would eventually get the desired workloads down, and that's why it scales in this manner of the agents pulling the information that it needs, and instead of having a central hub just trying to push all these resources and trying to reconcile and checking with all the clusters to see if they're there or not. Let me see if there's questions in the chat. Let me see. Yes, there's many resources. People were asking if there's resources or presentations. There's a blogs list, a reading list in here. Some of them are from Paolo and Andy. I think Paolo did one on Q. So they have examples on what we Q, one with Kubeflow. They have Argo workflow example, Q. Where's the Argo workflow? I think it's a little bit better. Andy has some of the examples with cloud. And also they have a YouTube channel. I don't know if it's on here. Yeah. So if you go to community, get involved. Like I said, they should be adding the Slack. Oh yeah, the Slack is the best way to reach them. Sync, if not GitHub. And then the YouTube channel actually is packed with a lot of presentations. Yesterday I was watching a few. Some of them are from KubeCon. Some of them are from their community meetings, and then they have something called demo days, where they show different use cases. Even a study that they did on Argo CD scalability, syncing 10,000 Argo CD apps, and how long does it take to get those app sync, and then using this technology of OCM and agent-based model. It's something that actually the Argo CD community is looking. We have a experimental project of creating an Argo CD agent model to be able to scale in this manner. So it's a proven architecture that other projects are adopting of an agent that eventually gets its information as it can, because it can have different speed, right? A cluster can be connected at 100 megabits, certain bandwidth. Maybe it's offline for a large amount of time, and it can get that information. So yeah, the Slack and the YouTube and the blog have been good. And then also the docs, I think they're very useful. So if you want to get started, they have in the documentation a getting started. So we just saw what is the KubeStellar, the architecture, that goes over that, and then related. Yeah, I think that's the architecture is the main concept here that I explained. And then they're getting started. They have a step-by-step on how to deploy this, or they have a quick automated setup. So what I recommend is, if you're trying this today, just go with the quick one. They have a shell script that can do create a demo environment with 3 kind clusters. One will be the hub cluster, and then the other 2 will be cluster 1 and cluster 2. So when you run this, you basically copy paste this, go to your terminal. For example, if I go here, let's do that. So the script will check that you have things like kind. So I have kind. Let me see, tell me, Jorge, if this text looks okay or not. There's some chats saying Kubernetes does not tolerate more than 40 seconds disconnected from a node. Yeah, in this case, it's a cluster, which is the thing that is remote. So it can be days disconnected, and then the agent will come back. Kubernetes has master and worker nodes. This is called control plane, not master. Core.
Are you?
So yeah, I think it's some of the maintainers asking question, answering the questions.
Sorry,
yeah.
Are you typing? Because I can't see that. Oh, I see your mouse moving. Never mind.
Yeah, I was kind. You can
there
see
we
now?
go. Yeah.
Yeah. So yeah, the script would install some CLI. So I think it's which. So I'm not going to run the script because I already ran it, and then it would mess up things because of demo gods, right? So kubectl, things like, and they have the prereqs here. Let me check the prereqs in the website, then, and it'll be better. Where's the prereqs? Gonna set up, overview, setup limitations, prereq. So yeah, you can do K3, actually K3D kinds. So you have to have a kubeflex CLI, the OCM CLI, Helm, and kubectl, and then kind. I think that's it. The other ones I think are for like software development and testing. So those one I have in my setup. So if I do which Helm is there, if I do which kubectl is there, which cluster ADM is there, which kflex is there. So you can install the system with kflex init, or you can install the Helm chart. I tried both. So in this case, let's take a look at a simple example. So if I do kind, if you're familiar with kind, you will know these commands. If I do kind clusters, I have, when you run the script, this cloud one is the one that I'm using for deploying from a Kubernetes cluster that I have in a cloud provider down to a kind cluster in my computer. Right, the kind cluster in my computer will pull the manifests from the hub cluster. So if you run the script, you will have 3 clusters essentially. So kubeflex, and the way this works is when you run the script, which I have in my notes, I run that script. Basically, it will go over installing the 3 kind clusters. It will install the kubeflex core system into the kubeflex cluster, and then it will install 2 API servers, one the ITS and one the WDS. So there's 2 clusters inside the kubeflex, and then basically you run that, and then you will have these environment variables that I will have here to use. I think I have them here. Let me add them here just in case. Right. So, and then you will kind of do the exercises. So let's go to the exercises. After you set up this with the getting started, you run it, and then you go and then run some of the exercises here. No, they're not here where they are. I think at the start, sample scenario. Yeah, I think it's the example scenarios. Let me move this to the side. Move this to the side so I can have 2 windows. And if we want to look around, we can take a look at the managed clusters. But before that, I like to take a look at the hub cluster. So if I do k-context, what is it? Host context, which is that kubeflex get namespaces, right? It deployed nginx. It deployed, let me go and do get pods -a. I don't think we need this anymore. Sorry about this. So in this system, it deployed there's two Kube API servers running in here. This is one, which is, I just explained, is ITS. It's the inventory and transport. I think it's called transport. And then the other one is WDS, where you deploy the workloads and then they get projected. So the remote clusters are connected to the ITS system to get its information down. WDS is the one that is going to do the binding policy with the workloads that you deploy, but they actually don't run in this cluster. And then the other clusters, you join them. So basically, you install some agent, and the way that it connects or authenticate is using the CSR. So you will create a CSR on the ITS cluster API server that it will connect to, and then you accept them. So if you do cluster ADM get token with I think it's called ITS 1. Let me get that thing. ITS context. I don't know what this is, caps. ITS context. Then you can take the cluster admin join. So it's similar to kubeadm. You go into the cluster, one of the clusters. So if I do kind get clusters, I have cluster 1 and cluster 2. And if I want to see what is in there after I did the kubeadm, the script did all this. So when you're running this in your computer, it created the clusters, it created the control plane, it created the two clusters 1 and 2, and then cluster 1 it got joined to the main cluster. So if I do a get dash context, this cluster 1. It's a cluster 1 WEC name or WEC. Yeah, it's the same thing. Since there's a lot of context, it's better to use environment variables. K context, and then I could get pods -a. The only thing that gets installed, so this will be your remote clusters. The stuff in kubesystem that was already there. So what it added was this open cluster management, 3 namespaces. Clusterlet is terminology from OCM, but that's the agent that connects to get the workloads down. And then the status agent is the one that pushes the status up. So let's get started. So if I deploy a binding, so this is a binding here. I think I have the YAML file here. Let me show the YAML file. I think I can close this. So the way you start, you can deploy a workload and then the binding policy, or either one. So let's look at the binding policy. I'm running version 0.25. So I can deploy a binding policy that says I want all the clusters that have this label, match label, selector, location, group, edge. And then I want the objects that have selecting the objects with the match label that has a label nginx. And then the status collection we'll see in a minute of like, how do I collect back the status of the deployments? So we want to see the clusters. Basically, we do k -- context. I think this is ITS 1. Get manage clusters. Manage, if I can spell. Right? So I have 2 clusters that I can deploy things to. I can do show labels, and as you can see here, both of them have name cluster 1 or name cluster 2. If I want to send it to both have the same location edge. So at this point, I can deploy this binding policy. So I will do a k -- context. I think it's WDS 1. Apply -f, and then that YAML file. And I don't know why I'm in the wrong folder. Apply binding. I'm in the wrong folder. Let me look, go into the right folder. Chat, back off. 2024, 12. Okay. So let's try again. Binding policy.yaml. Okay. So it looks like I already did that. So if I do K, I do the same thing, I get it back. So I apply this. That when that binding runs and I have the clusters and I have the binding policy. Now I want to deploy an app. So I can deploy this nginx that has this label. And basically I'm going to deploy a deployment. It's going to be in the default namespace. And it's just nginx that I want to deploy to those two clusters. So if I do K apply, so in this case, this context WDS, it acts as a normal API server. It has less API resources, so I can do API resources. I think it is. If I do count, it's 62. Normally, this API server, if you use normal Kubernetes, will be 150 something. So it has less APIs and it doesn't handle the deployment. So look at that when that happens and explain why. So let's see, deploy it. So I'm going to, hopefully the screen still looks okay. I can make it bigger. So I'm going to apply this nginx. So can do cat nginx. So I'm going to deploy this and I want it to go to whatever cluster has those labels. Or I can specify this deployment goes to that cluster, this deployment goes to that cluster, or it goes to a group of clusters. In this case, it's a group of cluster. So if I do k -- context, apply, yeah, that's what I want. That's get deployed. If you check the status of that deployment, you can say get deployment. There's no pods running. And that's the idea. There's no pods that are going to run in the hub cluster. The idea is I want to project this deployment YAML down to the cluster. So now the clusters are checking if there's any workloads for them. And then once they see the binding will create the manifest work. And then once they see the manifest work, they will pull it down. So in that case, I can actually see if the binding policy is picking up any matching workload to a cluster. So I can do that with get, I think it's called binding. So this is what it gets reconciled. So there's one binding policy. For the binding policies, has the same name as the policy. Let's check the YAML to see what's the actual work. So there's a spec, and the spec has that there's two destinations. So based on the label of, what was it? Location group, it found two clusters. In the ITS, it says, I want to deploy to these two clusters. What am I going to deploy? I'm going to deploy the namespace scope. And there's namespace, so you can also deploy cluster scope resources like cluster row binding, CRDs. So you can actually deploy a whole project or deploy the whole add-on. If you have add-ons for that cluster, you can deploy them. So in this case, I'm deploying a type of deployment on the namespace default, the name of that deployment. And then the status collection is something that I would show a little bit later. If I want to check, I think the CRD is called manifest work. Let's see how we do that. Or maybe just check the cluster 1 and cluster 2. So let's check k -- context cluster 1, get pods maybe, or get deployments, maybe deployment. So as you can see, this is what got deployed there. That deployment. If I do cluster 2, actually, let me show the pods, right? That's the thing that is running. Get pods, right? So that I got that pod, and it looks like I deployed this yesterday. I can also undeploy and deploy it again. So let's see if we can break something today. I can do delete. Oh no, wait. Context WDS1 deletes this deployment -f and Nginx. Boom. Now it's deleted. Let's see if cluster 1 and cluster 2 now doesn't have those pods. They're gone, and the deployment is gone. And of course, I only have 2 clusters, but I could have like 100 clusters, and all of them are looking for that binding information. So since there's no workloads, I think the binding now will have that I have destination of 2 clusters, but nothing to deploy. If I want to deploy any YAML file, right? But it needs to have the selection. Like I need to be able to select of the resources, like by labels, and also type of resource. I can say that it has this label and it has to be a deployment. Then it will pick up that work. If I want to deploy it again, I can deploy to WDS. Oh no, wait, I can apply the deployment, and I can check in cluster 1 and cluster 2. Actually, let's check cluster 2. And cluster 2, 5 seconds ago, we have a deployment, and we should have pods. And we have pods. In cluster 1, we can do the same thing, and we have pods. So that's basically the first concept of KubeStellar: be able to have remote clusters anywhere, and then be able to join them. How we doing time? Okay, so let's move on to the next section, which is I want to deploy. Well, let's do status, or let's do the OLAMA. I think let's do GenAI. Let me see what's the vote in the chat, if they want to see statuses or want to see GenAI. You can select objects to deploy. So it looks like the maintainers are answering questions there. Any rule we apply on Nginx for routing traffic for Nginx? You can apply traffic rules in terms of like, basically it's the equivalent of like applying this Nginx on there. There's also a concept of transformation. Sometimes, let me show that example. There's a concept of transformation. Let me see where that is located, that information, API. So we talk about binding, right? Actually, Go implementation overview. So there's documentation needs to be a little bit pumped for this project. Some places they have like to do write this for real. It's very amusing. The binding information is what I just deployed. Was the deployment, and you can see here I was mentioning the match selector, but also you can have resources. You can also say create only, right? So if some things are already created there, maybe you don't only want to create, you don't want to apply something on top of it. Also first creation. You can have multiple object selections, right? This is an array of things that you want to match. And I was going to talk about transforming. So sometimes you need to, when things get down to the cluster, there's specific things that are in the hub cluster that you don't want projected down to the hub cluster. So things like if the status field is there, it would not be down. For service, things like that are specific, like IP family and things like that, would not be sent down. For jobs, things like spec.suspend will be removed, and then you can there's a transformation that will add it back, so you can like tweak. I think there was one with a template expansion. I think this one. So for example, if you're going to deploy this one, cluster log forwarder. So and these individual clusters, you want to configure logging, but on certain clusters you have to send information in certain places, then the same YAML configuration cannot be identical on all the clusters. So you can have this template expansion to get information from certain variables, in this case cluster name or cluster hash, to compose information about what you want, or just change some information. So that's transform. Let's take a look at another example. So another example that I have is, let me see if it's here. I have another hub cluster. In this case, I have it in the cloud. Let's see where I have it. I think I need to log in. Let me log in for a second. I'm logging into a cloud provider where I have a cluster. In this case, I have a Jetson in my desk that I want to connect somewhere. I didn't want to connect to the Kine cluster in my computer because it's localhost and it was a lot of problems. So I just created a cluster in the cloud. Let's see if it's here. Yeah. Okay. So I created a cluster in the cloud provider. It doesn't have just a default configuration with EKS auto mode. Compute is based on Carpenter, so if there are any pods in there, they will run. I have the kubectl. I think I do the kubectl here. Where is it? General. See what is in this cluster. Come on, give me a shell. Let me see if it's set up already. So if I do k equals alias, I think this is very small to see. Alias kube k equals kubectl. Get pods. Yep. So I installed this on the internet. I have a load balancer and I have some ingresses. So if I do get ingress -a, I have Carlos. I deploy, basically I created an EKS cluster auto, deploy the Helm chart from KubeStellar, and I pass one parameter, extra parameter, which was the domain. So I passed the domain and I created the ITS and the WDS. So this is the same thing that was in Kine cluster. And now I can register things to it. So if I switch back, I think I have it here. Get config, get contexts. So I have it. I think I have it here. I think I have it in the main. I think I have it. Let's see. Yeah, I think I have it here. So I can do kubectl. I think it's this one. Yeah, kubectl config context ITS1, which is in the cloud, get managed clusters, and I have a Kine cluster and I have a Jetson. So in my Jetson, what I did was the same command that I did here: cluster ADM get token, and then I went to my Jetson, which is here. I can do SSH. I don't know why this thing's saying SSH. I don't know what's wrong with that thing. Jetson. Yeah, so I'm inside my Jetson. And this Jetson has a GPU. So if I do JTOP, has a GPU that we can see the performance. But before that, I can do k get pods, get namespaces. And I did the same thing. I did the kube ADM join. with the token, it got registered, and then I have the open cluster management clusterlet running there. Share drop, Jorge.
Whoa, what happened there?
It went away and then came back, right?
Yeah, it just kicked us all off real quick, but you're good now. Chat, we okay? It looks like we're okay.
Okay. Yeah. So let me run this demo. So what I want to do is from that cloud provider, right? That I have the EKS cluster. I install that, and then I install the Jetson, and the Jetson is running locally, right, in my computer. So the cloud provider doesn't have access to my Jetson, but my Jetson can go to that URL that I show with my domain name. So if I want to deploy something, I can deploy something like, I can create a YAML file or a YAML file like this. And I'm going to use Olama, which is a project that can run LLMs, and a Olama UI, which is a nice UI that is like a ChatGPT type of thing. And I want to run on my Jetson and use the GPU of my Jetson. So these are the YAML files that I want to deploy. I want to deploy a namespace called Olama, a PVC, a persistent volume chain to store the models as they get downloaded, persistent. And I'm going to deploy a deployment. And all of these have a label called Gen AI enabled. That's how I'm going to select all these YAML files or resources that I want to deploy to my Jetson. So this is Olama with the Olama image, and take into account that this image would not run on the cloud provider because cloud provider nodes are x86. In my case, I'm just using x86. And even if the GPU, these images are specific from the Dusting Jetson Containers project, is specific for the Jetson. So this is the image I want to use in the Jetson. It's going to be on port 11434 with that PVC, and then the UI is another stateless microservice, Olama UI, and this one is the normal one. This image supports both ARM and AMD64. So in my case, in Jetson will be ARM based. So it has a multi-architecture. Then a service to expose the Oyama, and the next service to type of load balancer, so I can get an external IP with Meta LB for the UI. So all these YAML files basically have the label Gen AI enabled. I went ahead and what I did is, let's deploy it first. So if we do WDS, I think I already deployed it, but let's try again. That's it. Apply -F, and is olama.yaml. So everything gets deployed. If I get deployments, right? Well, this is the nginx -o yama -n yama. If I can spell correctly, let me clear the screen so I can see it. So the two deployments got there, but there's no pods because the intent is not run pods on the hub cluster. And then if I get the services, for example, -n oyama, I get the two services in there. It has all the it thinks that it's a valid service and it's trying to find pods, but it's not find them. But this is not intended to be used in the hub cluster. I just want to send these two services, project them down to my Jetson, which is a managed cluster. So once I have this, I can create a policy. In this case, I'm using the latest version 0.26. So I can create a policy here, which is I want to select clusters that have GPU enabled, and I want to send down to those clusters any resources or objects that have the label Gen AI enabled. So it will be the service, the PVC, the deployments will be sent down to the cluster. So I think I show the clusters. Let's see where I say the clusters. That's that show labels. Hopefully the Jetson one is the one that has GenAI enabled. The other one is a kind cluster. It doesn't have GPU enabled. So right now, at this point, I can deploy this policy. So let's deploy it. The policy is binding policy 026 GenAI. Already did it, so that's why it says on change. And then I can go to my Jetson and see if I have. So as you can see, 85 minutes ago, I created the OYAMA. So I can do the K get deployments -o YAMA and have deployments, and I can have also pods and I have services. Let me see all of them. So I have OLAMA, OLAMA UI, the service, and then the service has a load balancer with MetaLB. I have an IP address assigned that is local to my house, so I can open this in a web browser. Let's open a web browser here. And I have OLAMA UI. And just to show here if this thing is using my GPU or not, sometimes if you not set it correctly, it will use the CPU, not GPU. But in this case, the GPU is not working. So if we take OLAMA UI for a spin, so I didn't have to do GitOps. I didn't have to install anything. Just this little agent sitting in my Jetson is just pulling configuration from the cloud as I deploy to that cluster that is sitting in the cloud. And in here, I can say, I can select one of the models that are already in my Jetson. I can select Llama 3, and it's a ChatGPT, so you can send any prompt files or anything like that. So I don't know if somebody in the chat wants to give me a prompt, a funny prompt to do. Or we can say something like, should I use service mesh on Kubernetes or not, and why? Maybe people have been asking that and they don't get straight answers. So let's ask GenAI to see if it gives us what answer does it give us. Let's see the GPU. So the GPU is going green. So it's 99%. It's at 100%. So that you can verify the GPU is actually doing. Then you can do CUDA, NVIDIA, PyTorch, all those things. But in my case, I'm using this example. So it says using a service mesh of Kubernetes depends on your specification requirements, applications, architecture, and organization needs. Here are some points to consider. Pros of using service mesh. And then it says cons of using service mesh. Additional complexity. Introducing a service mesh adds another layer of abstraction, resource utilization, interoperability issues. So it has pros and cons. And yeah, I think that's the demo of deploying. One final thing, let me show one cool thing is if I were to go back to my system, and let me just go to this one. And you saw that in the binding policy, I selected, this one doesn't have it. Maybe this one has it. In the binding policy, I selected that I wanted to play nginx, and then you can collect the status of the deployment back, so you can have like the full status of the deployment, or just count them. It has a concept of using SQL for these combined states, so you can collect from these resources using select and SQL, but you're going to express it in this YAML as status collection. So I have a couple of them, so I can do like, I want to count how many replicas are available. I can say I want to know like how many deployments are in each cluster, or I can say give me everything, give me all the status, return the status from every deployment, give me the name of the cluster, and give me the time that you retrieve this information. You put that in the binding, and then it creates an object called kubectl --context. It's called, this will create a combined status, and then you can inspect it. Let me see Dutch or YAML. and then in the roles, in the status, then you will see kind of like a table format information. So I will have, in this case, I have like 3 tables because I created 2 SQL statements. And then one is the like how many clusters have that deployment is 1 because I was deploying to 1, the cloud. Another one is the status of all of them. I can do this also for the other one. Let me see. This one is a little bit better. kubectl -- context. Combine statuses. Let me see. This one I think is deploying to 2. So this one is the something. Yeah, this one has a little bit more meat because I'm deploying the Nginx to 2 clusters, to cluster 1 and cluster 2. One thing that we can do is take this and maybe we can ask, I haven't tested this, so let's test it here live. I can go back to the UI. Where's the UI? Gen UI, and create a new chat. And let's see if Oyama 3 can give us, let's see, generate a nice text print tables for this info. See if this works or not. No, I'll do it here in my VS Code. And we'll conclude with that. Let's create a new chat and say, generate a nice text print tables for this info. And wait, I'll do it again. Including JSON is YAML is try again. Generate a nice table, maybe Markdown, explaining this info from YAML. Okay. Let's see if it explains what is in there. It should explain what we did, right? Deploying Nginx, that we have 2 clusters. Explain that 2 replicas are ready. Cluster 1 and cluster 2, they're available. I can ask for the HTML version. And then you can put that in a UI. So I think that's it. Try to cover everything in 1 hour. Yeah, Jorge is saying that we're out of time, but yeah, check out the project. Was able to set it up in 1 day, both in kind and in the cloud. And then I was able to use my Jetson device to connect to it, and it's pretty straightforward. The authentication happens through certificates. So you create a CSR in the hub cluster, similar thing as kubeADM, and then join the cluster, and then the bindings will start deploying your workloads as you deploy them in the hub cluster. I think that's it, Jorge.
I think that's it as well. All right, thanks for everyone for showing up, and we're here next week, and then it's the holiday week after. So I will see you.